To make this bee fight into an interesting encounter, I want to give him a couple of different abilities. The first is going to be this lightning shock that fires these little sparks, and you can see it's on our platforms that we've already created and also on the ground. Now, the way that it works is through a script that allows me to completely adjust and modify this. If you take a look at my bee encounter script, you'll see I've got all kinds of lightning elements here and a bunch of different settings that allow me to change the way that this works. I can adjust the number of simultaneous strikes, I can adjust the delay between the strikes, and I can adjust how long before the player takes damage, and of course I could move these lightning areas all around if I wanted to. So here it's what we're aiming for, and now we're going to go through the process of creating it. So here's where we left off. We've got our platforms with the lightning auto playing, and our bee has gone back to his home position. We need to set up the script now that's going to control these lightning blasts, make the player take damage, and maybe add a couple more lightning strikes down on the ground. So to start, we're going to create a new script. We're going to go into the scripts folder. I'm going to shrink this down with control on the mouse wheel. Right click, hit create, choose C# script, and we're going to call this bee encounter. Again, no spaces, but a capital B and a capital E. We're going to select our bee encounter object. This is the parent, again, not the one that actually has the bee on it. So if I go to my bee encounter, remember it's at 0, 0, and then underneath it, there's a child of a bee visual that, the bee root object right here that I can turn on and off. I'm going to go to the bee encounter, that parent. I'm going to minimize the audio source, and I'm going to add a bee encounter script to it. Then we're going to open that script up and talk about the code. Here's our bee encounter script, and before we get started, I want to mention that when it comes to creating a scripted encounter, there are definitely a couple of different options. We can write out some code, we can build some data-driven solution, or we can do some sort of visual scripting option as well. They're all somewhat valid options, but typically, in most games, what I recommend to start with is a simple scripted setup. You don't really want to start abstracting and building up state machines and script stuff until you have a good idea of what it is you're going to be building, how much of it you're going to be building, and who's going to be building it. When you get to the point where you've got other people that are game designers that have no programming skills working on stuff, you want to start to look at some other options. And as things grow and get bigger, you do. But when you're just trying to build out a nice, tight, good encounter, it's drastically faster, easier, and a lot easier to just get done quickly. Well, not just quickly, but quickly in the exact way that you want if you write it in code. So that's how we're going to do this. And we're going to start by just removing the start and update methods completely and adding an on enable. That way we can toggle this object on and off, and inside of this on enable, we'll kick off a coroutine that runs our encounter. So here we're going to add a start coroutine, and we're going to call this coroutine start encounter. I'll add my parentheses, generate a method with it, Alt-Enter, and then we'll change the return type to not be string, but an IEnumerator, which is the one thing that Visual Studio constantly gets wrong. It always wants to put a string there, but it should be an IEnumerator. I'm going to remove my private keywords, and then let's talk about what our start encounter method should do. The first thing I want it to do really is disable all of the lightning. I want to turn all of that lightning off and then randomly pick some lightning and just turn one of them on. And I think I'll start with that and then expand from there, because the next thing I want to do is pick multiple and have them all turn on, in an order, and do more of the actions like we described. So let's start by just turning off all the lightnings. To do that, we'll say _lightning, or let's add a for loop instead, delete that. For each var lightning in _lightnings, and then we'll say lightning, not _lightning, lightning.gameObject.setActive to false. Now we don't have a lightnings array here, but I'm thinking that for our lightnings, we're either going to want to reference the transform, the animator, or the game object. I'm not sure which one yet, so let's just start with the transform. I'm going to copy lightnings. Actually, let's just hit Alt-Enter and generate a field for it. And we're going to change this, instead of being an IEnumerable of object, we'll make it a list of transforms. transform. I got to get rid of that S. We'll make it a serialized field so it shows up in the inspector. And then we'll have to do something after our start encounter. So this right now should loop through all of our lightnings, set them to inactive. And then let's do a yield return null and save. We'll go into Unity. Let's assign our lightnings real quick. Make sure that this turns them off when we enable it. And then we'll finish up the code after that. So we'll go expand out our lightning objects. And I don't want to grab my B platforms because I don't want these things turning off. I want the lightning objects underneath it. So I'm going to go back to my B encounter. I'm going to lock the inspector so that it stays on the B encounter. Then I'll go expand out all of these B platforms. I'm going to go to the bottom one, hit right arrow up, right arrow up, right arrow up, right arrow up. And then go find all of the lightning objects. I'm going to hold control and click on all of them. There should be 6 of them so far. And with all of them selected, I'll drag them right into lightnings. Now, if you messed one up, you can always just say it's that one right there. If I remove that one from the list, did I remove it? There we go, hit the minus key. Then I can always just click that single one that I missed and drag it in or clear it out. Just make sure that you've got all of your lightning objects there. I'm gonna press play, and when this enables, it should just turn those off. If that's good, then we're good. So there we go. It looks like it turned off all of the lightning objects. Let's stop playing and jump back into code. Now to turn a random lightning object on, we're just gonna at first choose one at random and flip it on. Now to choose one at random, we just pick a random number between 0 and the number of lightning objects inside of our lightning list. So to do that, I'll say var, or let's just call it out as an int. Int is the same length as var. And I'll call this int index equals, and we'll use random.range, and here it's not going to autocomplete because it's finding system.random, not unityengine.random. And that's because I have a using system statement up there, which is because something in here is using it. Oh, I think it's the serialized field attribute. Let's see, let's remove the using system statement. And you can see that now, now we're good. I guess I wasn't using the system statement. So we can do random.range from 0 up to lightnings.count. Now, if we do need to have the using system statement up there, by the way, we can also just add Unity engine right to the front of random. So we can use the Unity random generator, not the Microsoft.NET system random generator, which is a slightly different random generator that requires you to instantiate it and deal with the seed. It's a little bit more work than the Unity engine one, so I prefer to use that. So now we've got a random index. We'll turn on the object at that index. So I'll say underscore lightnings at index. There we go, .gameObject.setActive true. It already knew exactly what I wanted to do. And then if we want this to just repeat, we'll just wait. So we'll say yield return new, wait for seconds. And here we'll add in our delay between lightnings. Let's make that a variable. And then finally, we'll just turn this into a loop. Let's actually first, before we do the final part, generate a field for the delay, turn it into a serialized field, and then give it a default value of, I'm going to go with 1. So now we've got our code. We just need to make this into a loop. So I'll say for each, or not for each, while true. And we'll add braces around it so that all of the code inside of the braces will run permanently or indefinitely. It's going to run forever as long as this coroutine is running. And it's just going to loop over, keep despawning them all, and then spawning the next one. It's going to actually despawn it a little bit early, though. It's going to despawn it before the lightning finishes striking. Let's go check that out. Make sure that it's doing what we expect. There we go. Go over to the lightning. We can watch it. You can see the lightnings appearing and then quickly disappearing. The reason for that is that the delay between lightnings is 1 right now, but the animation takes 2.5 seconds. So if I change this up to about a 2.5, I'll pretty much get a consistent nonstop lightning strike applying at one of these positions. So we're part way there. We've got a somewhat interesting setup. I think the last thing I want to do is change this to a 2.5 and save my scene. And then I'm going to commit this and we'll talk about how we can make it a little bit more complicated. Let's say added basic lightning control to the B encounter. And let's check that in.